Hello everyone, welcome back to my YouTube channel. So this is a video lecture on digital switching system. In this video lecture series, we are discussing module number 3, that is telecommunication traffic. So we are discussing the queuing systems, and in that the sub part that we are going to discuss today is probability of delay that are happening whenever the incoming lines, that is incoming calls, are more than the number of trunks, that is n. Okay, so the delay occurs if all the servers are busy, that is x is greater than n. Now from equation 4.11, that is the equation that we discussed in the previous lecture, that is this equation p of x is equal to n to the power of n divided by n factorial a by n to the power of x multiplied p of 0. That is what we are discussing the second Erlang distribution formula. Now that using that formula, the probability that there are at least z calls in the system is given by, okay, that is the probability that there are at least z calls in the system is given by probability of x greater than or equal to z is given by summation ranging from x equal to 0 to infinity p of substitute p of x over here, then we'll get the next step, that is n to the power of n divided by n factorial p of 0 summation ranging from x equal to z to infinity a by n to the power of x. Fine. Now if you split this limit, that is x is ranging from z to infinity, right? If you split that, if you take z only out, then you'll be having this step, that is a to the power of n a by n to the power of z multiplied by summation of k equal to 0 to infinity a by n to the power of k, and where k is equal to x minus n, that is number of trunks. Now if probability of x greater than or equal to 0 is given by n to the power of n divided by n factorial a by n to the power of z, p of 0 multiplied by 1 minus a by n to the power of n. That is, this summation from k equal to 0 to infinity a by n to the power of k. This term is replaced by this term. How is the it is coming from the previous derivation? Okay, we're discussing second Erlang distribution. We had seen this equation. Now we have summation from k equal to infinity a by n to the power of k. In place of this, we are writing this in the equation over here, that is this summation is replaced by this equation. Fine. Now let us go further. If you solve it further, simplify it further, then you'll get it as n to the power of n divided by n factorial a by n to the power of z, n divided by n minus a multiplied by p of 0. That is, in the bracket we have 1 minus a by n. If you take a LCM, it will become n minus a divided by n, and inverse is there. If you inverse it, then it will become n divided by n minus a. That is what is done over here, n divided by n minus a and multiplied by p of 0. Now the probability of delay PD is equal to probability that x is greater than or equal to n is given by PD is equal to a to the power of n divided by n factorial multiplied by n divided by n minus a into p naught, and we denote this equation by E2 comma n of a. This is the probability of delay for a system with n servers offered a traffic of a erlongs is given by this equation. The meaning is the equation, that is 4.15, is the probability of delay that is uh, possible to occur whenever we have n servers and the traffic of a erlongs is given. And this formula, that is equation 4.15, is known as Erlang's delay formula. Okay, and just see here in this figure, what he's trying to say is, what he's trying to plot is the probability of delay increases towards 1 as a increases towards n. See here, we have the axis over here, the x-axis is traffic per server and this is the delay. So as a is increasing towards 1, then delay is also increasing. If n is 1, the delay is around delay is this much, the first code that you're saying. As the number of as a is increasing, the probability of delay is also reaching towards 1. That is what he is trying to say. So this is all about the topic probability of delay. Thank you.